Number 3. For cones with radius of 6, the equations v equals 12 pi. H relates the height of h, the cone, in units, the volume v, and cone in the cubic units. Okay, so how are they getting this formula? Well, if the radius is 6, right, you have pi 1/3 pi r squared times h. Well, 1/3 times pi times 6 squared, which is 36, times h. 1/3 of 36 is 12. So if you're trying to square stuff, it's not going to work out. That was already done for you. This is the equation. This is all you need. Then you have volume as your dependent variable, height as your independent. So I should have seen a table on your paper with the independent value and the dependent value. Now, a lot of you were saying, I don't know the height. I don't know the height. Yeah, you guys, you got to pick one. There's 10 of them. The height is 1, the height is 2, the height is 3, the height is 4. Then you plug it into your formula. Your answer is the volume. Together, you make points on the graph. So I'm going to pick a couple. I'm going to say 1, 5, 10. So I can space them out a bit. Okay? When the height is 1, my formula is still 12 times pi times height. So 12 times pi times my height, which is now 1. Pi is 3.14. Do not use the pi button in your calculator. We've not been using that. So 12 times 3.14 times 1. 37.68. That is the volume when the height is 1, according to that formula. Well, what if the height was 5? 12 times pi times 5. 12 times 3.14 times 5. 188.4. And 10. 12 times pi times 10. 376.8. Okay, so I've got 3 values. They're spread out so it can help me on my graph. When h is 1, it's 37. So think about, where does 37 compare to 100? It's about 1/3 of the way. So this isn't perfect. It's a sketch. Then when height is 5, it's 188. So a little bit under 200. And then when the height is 10, it's 376. So a bit under 400. Okay, then you didn't really have a ruler, but just making it easier. I'm going to connect them roughly. That looks like a straight line to me. But, so now I'm going to say, yes, there's a linear relationship because it makes a straight line, right? Which a lot of you said, which is great, but you got to prove it. What do we need to know it's a straight line? That it's always going the same exact increase or decrease. You need a constant rate, right? You need to be able to say, well, y equals mx plus b. This is a straight line formula. So what is our slope? What is our constant? Using your table, this is why it was super helpful to make a table, you should divide and see if you're getting the same proportional relationship. So if I do my calculator, 37.68 divided by 1, I get 37.68. Next, if I do 188.4 and I divide it by 5, what do I get? 188.4 divided by 5, 37.68. If I do, oops, dropped my calculator, 376.8 divided by 10, I'm going to get 37.68 because I just moved my decimal one over. Every time I'm getting this value, this is my k value, this is my constant proportionality. So I would say the constant rate is 37.68 cubic units per 1 unit for height. So every time your height increases by 1, you go up by 37.68. Okay? I need to know the constant rate. You gotta talk about it to make it a line. Come talk to Miss Grew if you need help.